Hello, this is Whitney Otan, Geology Professor in the Department of the Earth Sciences, and I'm here today to explain the laboratory exercise in ESC 195, Natural Disasters. This week's topic is that of volcanoes. And as you know, volcanoes produce fairly large-scale landforms that are associated with tectonic processes. Basically, as plates tend to converge against each other, they can produce the melting of rocks deep in the subsurface, and these melting rocks can basically rise up to the land surface and extrude into the land surface and therefore become a volcanic landform. The volcano types that occur around the world vary as a function of some of the tectonic settings that they tend to occur in. The types of volcanoes are shield volcanoes, cinder cones, and stratovolcanoes. So basically, each of these types produce different types of magma or rock materials. They also produce different types of volcanic landforms, and then thirdly, they produce different types and levels of volcanic natural hazard potentials. So with that, first, shield volcanoes tend to be very broad in geographic area, and they occur because the rocks that are melting tend to be mafic in character. They have high iron and magnesium content, and as a result have very low viscosities. They flow relatively easily. Because they flow very easily, as a result, they do not tend to trap gases as effectively and have a much lower potential to explode. An example of a shield volcano is that at Hawaii. And so, as a tourist, one can go to Mauna Loa and go to near the top of Mauna Loa and actually watch the lava flowing down the hillside. The hazard potential is extremely low. Now, cinder cones, on the other hand, tend to occur in volcanic terrains where the rocks tend to be a bit more felsic. Felsic rocks contain higher proportions of silica and aluminum, and the silica and aluminum content tends to produce a higher viscosity. As a result, the lava tends to be stickier. It does not flow as readily. It can plug inside of the volcanic vents as it tries to rise to the land surface. It can also trap significant quantities of gas in the magma as it's trying to rise to the surface. As a result, all of these characteristics put together can produce a tendency for greater risk of volcanic explosion. And volcanic explosions, as you know, tend to be associated with higher probabilities of natural disaster potentials. So volcanoes that carry this kind of characteristics tend to occur along the Pacific Northwest of the United States and also South America. Now, the third type of volcano is that of a stratovolcano, and stratovolcanoes are the result of successive layering of volcanic eruptions over geologic time. Stratovolcanoes generally have complex eruptive histories and may erupt successively for over a period of time, then become dormant, and then become active again and erupt with another succession of lava flows. So as a result, stratovolcanoes can be a little bit difficult to predict when the next eruptions are going to occur because they have the potential to become dormant for very long periods of time. But in summary, the nature of the volcano is related to the characteristics of the magma that are produced by the volcano, and the magma's composition, the magma's temperature, also the magma's volatiles, the gas content, all tend to be related. high viscosity, sticky lavas which trap a lot of gas tend to be explosive and potentially very dangerous, whereas lower viscosity magmas which flow very readily, have low gas contents, tend to have a much lower hazard risk when it comes to volcanic eruptions. So with that, hopefully you'll enjoy this week's exercise. This is Whitney Otan signing off. Have a good day.